Okay, today we're talking a little bit of a review of the x cubed function and the 1 over x function. Which one did I graph on this graph? That's x cubed, okay? And if I wanted to stretch this thing, remember when you stretch it in both directions. So if I'm going to make this twice as wide, look what I do here. I take that point and its original distance width was 1. Now I'm going to make it 2. This width, I'm making it 2. This width was 2, and now I'm making it 4. And this width was 2, and now I'm making it 4. Okay, do you get that that graph is wider than it was in the first place? All right. I want you to write me the equation for it. It's a fairly simple one. It was x cubed. You don't need to put the dots in. I just want you to write the equation for it. So it was x cubed. Now it got stretched and it's wider. And so here's the most common mistake right here. Seems like it's twice as wide if I do that, but that actually would be half as wide. So if I really want it to be twice as wide, do you get I had to put a 1/2 in here? Raise your hand if you knew it was a 1/2 in there. Okay, good. Okay, now, if you're just, now you saw me do that, so you knew that I made it twice as wide, but if you just had encountered this shape, how would you have known the stretch? What you do is you take the vertex of it, and then you say, well, it should be going over 1 and up 1. Do you get that there's not a dot where there should be a dot? That means that this has been stretched. Then the only question is, you got to try to figure out, well, where did the dot go? The dot that should have been here is actually moved over an extra 1. And I hope you don't think then that the whole thing got shifted to the right. You got to know, oh, okay, it got twice as far over, so I can do that by saying a stretch, or putting a 1/2 on the inside, which makes it go twice as wide, a horizontal stretch. All right, I want to give you another one. Take a look at this is, again, a parent function, and I'm going to just do it on the screen here. This point would not even be visible anymore, and this one would be like this, but I'm also going to grab all 3 points and move them over like that. Write me that equation now. So here's how your brain should engage on this. You should go, okay, I know that that was the x cubed function, so I'm going to start with that. And don't forget the y equals. If you don't have a y equals, it's not an equation, or an f of x equals. Then you got to ask yourself, okay, compared to a normal one, this one has been stretched because I know there should be over 1 and up 1. That spot right there is on pretty much all the parent functions, the over 1 and up 1. Look for that spot. And if there's not a dot there where there should be, then where is the dot? And the dot is up here. Now, does that mean the whole function moved up too? No, because this guy didn't, the original vertex point right there, that didn't move up too. So it's somehow going up to that. Oh, that must be a stretch. It must be, and the most common mistake answer is twice as high. Okay, this one's not twice as high. Compared to the original, it was 1. And now it times is by 3, makes it go 3 times taller. So you should add a stretch 3 like this, and then what else? Compared to where this would normally be, it is over 2 spots to the right from normal. So I have to have a -2 on the inside like this. Raise your hand if you had that one right. That's most of you again. Good. Okay. The next one is that other parent function. I'm going to get this out of here and this out of here. Once again, it's getting closer and closer, never touching, so it's the asymptote one. I actually made it touch, so I better fix that. And it goes like this. Remember this guy? That's the 1 over x function. Okay? Now, it's very difficult to tell if that one's been stretched. So it's not likely we would take that one and stretch it. Okay? But I could definitely see taking that one and moving it. So I'm going to take this. I'm going to move it to there. I'd like you to tell me what the equation would be for that guy. There's no stretch. If you want the asymptotes in there, I can draw them. And you should be able to also. I missed one of those just slightly, so there we go. Do you get how the asymptotes kind of help you to see how far it's been moved, left or right or up or down? Because those asymptotes used to be centered right on this, 0, 0, and now they're here. So that kind of tells you, oh, things have been moved this way. All right, I want you to compare with the kid I paired you up with before. And Mr. HM, would you also help LH in front of you? All right, this way, this way. Check with the person that you paired up with, please. See if you have the same answer as them. You're writing an equation for this? You start with 1 over x because that's the parent. Okay, you should have said this thing got shifted 1 to the left plus 1 on the inside. And it's also shifted up 3 plus 3 on the outside. Raise your hand if that's what you had. Okay, good. Now this is one of the weird functions where if you flip it up, down, or left, right, it ends up in the same spot. If I flip this up, down, then this one here shifts down here, and this one here that was kind of down flips up to right there. Do you get how if you flip up, down, or left, right, you end up making this kind of like star-shaped thing? And it doesn't matter if you flip left, right, or up, down. The new function would not be here anymore. It would be where the black lines are. And I'm going to move my key parent points right there and there. Okay, see how that one's got a flip in it now? A left-right flip or an up-down flip, and you can't tell the difference. So in that case, you can put a negative in one of the two spots, but don't put it in both. Because if you put it in both, what happens is the thing flips to a different spot, and then it flips again, it flips back to where it was in the first place. Sort of like saying 2 negatives in front of a 2. It goes back to just being a 2 again. So if you said a negative here and a negative here, do you get why they would cancel each other out? It's like having 2 negatives in a fraction. They would just cancel each other out. It's like it never even happened. Okay. So if it got flipped, you'd want to put only one of those negatives in. And I'd just put that one in because it's a lot easier than trying to put this one in and forgetting to put the parenthesis on it. What I'm talking about? All right. Okay, so your assignment for today is basically a review assignment. And it was, again, about the 2 new paired functions. Last thing I want to talk about is those parent functions. And I really want to make sure you get all of the parent functions. I would like you, and this is kind of weird, but I'd like you to graph all of the parent functions you have learned on one graph. So insert a picture, a nice clean one. If you've already got one, awesome. And I'd like you to graph for me all 5 parent functions. Use different colors and put them all on the same graph. The cool thing is you'll see where they overlap each other. All 5 parent functions on the same graph. You need at least, well, some of them only have 3 points. Some of them have 4 points. Some have 5 points. I'm going to pause for a second while you try that. Okay, I'm recording again. So here are some of the parent functions. Who can forget the ramp shape? Over 9, up 3. Raise your hand if you have that on yours. Okay, good. Now I'm going to use a different color dot. I have another one here. Just give me a second and I can. There we go. I'll use that guy. And I'll make him an infinite cloner. Go. So this spot, the V shape, I don't need to make unlimited points on this thing. It would take forever, but basically you got your V shape on there. Raise your hand if you had that one. Did you see where they overlapped? 2 spots, right? 0, 0, and what? 1, 1. All right, now let's make another graph. This time I will make a purple dot, and then I will grab it and make it an infinite cloner. And now I'm going to make, see if you recognize the one I'm making now. Over 2 and up 4. 1 up 1, over 2 up 4, over 3 up 9. Did you see where those guys overlapped again? All right. Why is that so important that they all end up overlapping right there? Because you can look at a stretched shape, find the vertex of it, and assume it should be over 1 and up 1 if it's not stretched. If you go over 1 and up 1 from the vertex, and there's not a point there, then you know it's been stretched. All right, so along those lines, I'm going to get rid of all those points for a second here, and I'm going to make you one more. I'm going to see if you can write me the equation for this guy. I'd be off the graph anyway, so I'm not worried about it. All right. Tell me what the equation is for that one. It's been flipped. Forget that part. All right. So you got a y equals in your answer? You got a chance to have it right then. Okay. What else has to be in the answer, Mr. T? Agreed. That's the next thing you should choose is the parent. And this is the square root. And was it a left-right flip or an up-down flip? Left-right, which is also known as horizontal. It was a horizontal flip. Like the horizon goes left-right, you know? So if it's a left-right flip, horizontal flip, you got to go on the inside. And you got to go like this to your x. But you got to be really careful because is there anything else in there? Yeah, it's been moved which way? Left or right? It's been moved left too, so you got to go like this. I bet a lot of you forgot that parenthesis, but not everybody. And then last thing is it's up 3, which makes like that. And why would I still not have it right? Stretch. So many people forget the stretch. Now, do you get this guy normally should be over 1 and up 1. There should be a point right there. You get that? And now you can tell, since there's not a point right there, it's been stretched. And then you can say, oh, looks like it's up twice as high, twice vertically. Put a 2 right there. Did anybody have this one right? All right, if you didn't have it right, try to learn from that. That's going to be the hardest kind for you, I think. So I give you an equation. You try to figure out how much it's been stretched. The key is, once you know what parent it is, look for that spot that should be there. And if it's not there, like you're expecting it to be, figure out where it's been stretched then. Okay, that's all I got for you for